Hello guys, so we are going to look at differential equations. So in this question we've been given x dy dx is equal to y minus the expression square root of the expression x squared minus y squared. So without wasting much time, yes, let's dive right into it. Alright, so this type of question we are going to solve it using the method of separation of variables. Yes, so this means that we make x and the x stand alone and the y and the y also stand alone. Yes, but you can see that when we try using change of subject, it is going to be complex. So you can simply say that um, let um, y to be equal to ux. Good. So from here, then we can say dy dx is equal to u plus x du x. Very good. So this is the product rule. So in our next video, I would hit on product rule. Yes, just to explain that better. All right, so let's move on. So with this in mind, we are saying that wherever we see dy dx, we can replace it by that expression. So we have x and then the expression dy, du dx is equal to y, which is ux. So ux minus square root of x squared minus y, where y is ux. So we have u squared and then x squared. Okay, so let's deal with this part first. So we have square root of x squared minus sorry, good. So we factorize x out and then we know that when we have square root of x, it becomes x. So x comes out of the square root. Now we have 1 minus u squared. Okay, so we've simplified that part of the equation. So let's go ahead. The next thing that is that x into brackets u plus x du dx bracket close is equal to the simplified expression. So let's just write it there, ux minus x square root of 1 minus u squared. Good. Okay, so from here we can see that x is common between u and then x. Yes, so we factorize x out from that side. So let's rewrite this expression, x du dx bracket close is equal to x into brackets u minus 1 bracket close square root of the expression 1 minus u squared. Okay, so x is common, so we divide through by x, then we cancel out. So we cancel out, and then yes, then we have u plus x du dx is equal to, let's cancel out this, yes, good, u minus 1 square root of the expression 1 minus u squared. Good. So from here we could see that u is common, 1 is positive, they're all positive, so when they cross is going to get negative, so they cancel out. So x du dx is equal to minus square root of 1 minus u squared. We didn't write minus 1 because 1 is an identity element. Okay, so let's move on. Let's wipe this off so we can get enough space to work on what we've gotten so far. So Yes, wipe, wipe, wipe. Okay, I think you can now go ahead. You can go ahead. Okay, so now we have the equation to be. Okay, let's refer. So x du dx, let's write that. So x du dx is equal to minus square root of 1 minus u squared. Okay, so we multiply through by dx to clear the denominator. So multiply through by dx, yes, and then dx. So we cancel out dx. So we have x du is equal to minus square root of 1 minus u squared dx. Okay, so from the trig identities, yes, we know that when you have the expression, okay, let's divide through by square root of 1 minus u squared, so we can simplify it further. So as I said earlier, I said you make u be with du and then x also be with dx. Yes, so 1 minus u squared, then we cancel out. Yes, so x du is equal to, over square root of 1 minus u squared is equal to minus dx. Okay, now we can see there's x there, so we can divide through by x to make du and u stand, and then dx and then x also stand. So let's wipe this off. Wipe. I think I have to start a business as a wiper, because this is, I don't know, it feels good. Yeah. So yes, wipe. So I think we have enough space to continue with our solution. Okay, so what do we have? We have x du over square root of 1 minus u squared. Okay, let's write that on our next page. X du over square root of 1 minus u squared, yes, is equal to minus dx. Okay, so let's divide through by x as I said. So x and x cancel out. So finally we have du over square root of 1 minus u squared is equal to minus dx over x. Yes, so finally we've been able to separate the variables. Okay, so from here we know that from trig identities we can apply our integral signs. Yes, don't forget to do that so you can break it down further. We know that, let me wipe this and then Yes, we know that from trig identities, integral of the expression du over um, square root of 1 minus u squared is going to give us sine inverse of u. So let's write that down. Over square root of 1 minus u squared is equal to sine inverse of u. Okay, we are good. So let's wipe this off. Yes. So okay, let's wipe everything. Okay, so let's just copy what we have in our previous page and then rewrite it here. So rewriting the expression, we are going to get sine inverse of u is equal to um minus ln of x. Don't forget, when you integrate 1 over x, you get ln of x, and it was negated. And always don't forget your constant. Whenever you integrate, there is a constant. So don't forget, we also said that let y to be equal to ux, right? Now let's make u the subject. So we can say that u is equal to y over x. Very good. Now let's substitute this into the equation that we have and simplify it further. So sine inverse of y over x is equal to minus ln of x plus our constant, which is the c. And then we want y to stand alone, so we find the sine inverse of the sine inverse. Good. So that's going to give us sine. It's like having negative and negative. It's going to be positive. Good. So into brackets, negative ln of x plus our constant, which is the c. Yes. Now we have to make y the subject from here. Then so we multiply through by x. So we have x sine of into brackets minus ln of x plus our constant, which is the c. Yes, so we've been able to solve this question successfully. So let me clean here and then rewrite the answer there. Yes, so that is our final answer. Yes, wipe. Okay, so our final answer is going to be y is equal to x sine of the expression negative ln of x plus our constant of integration. Yes, so I think we have to clap for ourselves. Yeah. So if there's anything you don't get, you can probably do that in the comment section. Yes, let us know. So if there's anything that we need to explain further, we'll do that. Also, don't forget to smash that subscribe button and then like this video. Thank you.